Going forward now with Chapter 12, Alkanes, Aromatics, Compounds, and the benzene structure. As we talk about carbon, we have, going back to our orbital notation, we have an unhybridized carbon, which has S, which remember is a sphere. So we would have a sphere shape here, just close to the nucleus. The 2s would be a little bit larger out, a little bit farther from the nucleus. But when we get to the 2p, we now have this shape. We have it on the x-axis, the y-axis, and the z-axis. So if we were to write our Lewis dot, we would end up with something like this. But we know that most carbons will go like the right over here. Because what happens is the S that has to share a room comes up and gets its own room and becomes positive. When I do that, I make 4 equal orbits, and they end up looking like this. So we have a hybridized carbon. And a hybridized carbon likes to have 4 bonds. So when we do a triple bond, the first bond between any molecule is what's known as a sigma. A sigma is like shaking hands. It's in the S, or the first orbit. Okay? Then we get pi's, and pi's are from the P. So you can have a pi bond and another pi bond. Now, as I look at that, remember that these these orbits looked more like this with a little thing like this. So as I'm pulling these orbits together to bond, these two are bonding. And these two will be pushed out a little bit so that the bond can happen. So that's where the green and the yellow would bond. So we have a single bond, which most often is just written like this. A double bond, we go like this. Now this one is a 3D molecule, a single bond. When I get to a double bond, it's actually forced into a plane. You made some molecules in class, and when you did a double bond, you could actually lay this flat on the ground with the hydrogens here and here. But when I go to a triple bond, it brings it into a line where the hydrogen is right here. So it becomes a line. It's forced to be linear. Okay, so naming alkynes. Alkynes, let's go back here. Alkynes are just with triple bonds. So you have a triple bond, and you just name them like you would any other thing that was attached. You want to number the chain, the longest chain, to the shortest distance to get to that triple bond. So 1, 2, 3, 4, 5. So I would put on the first one, 1, and so there's nothing else I need to worry about but the wynie. I count 5 as pent, but instead of ane or ene, I put wynie. Now, as we go on and there's other things that are attached, we need to move that 1 inside. And so as we get farther along here, you'll see it like this. This is not meant to be an English class. It's meant to show you how structures are made. So let's do another one. Try it on your own, and then I'll come back. You'll need to pause the video. So say that I had this. Remember, Bond, James Bond, always wins. Pause the video so you can get a chance to do it on your own. Okay, so coming back, you want the shortest number to the bond that's changed. So you're going to number it this way, 1, 2, 3, 4, and just because I don't like to go in a straight line, I'm going to go a little bit down. Now, you know that I like to use blue for methane groups. So I've got a methane group here and a methane group here. I like to use colored pencils, and I assign each of them a different length. So as I'm doing all these organic molecules, it makes it very easy to name. So longest chain is 5, which is pent. It is a wynie because it has a triple bond. That triple bond is on number 2. Now I could have put pent to wynie like this. Okay, that's fine too. And then in front of that, I have 2 methyl groups. So I've got to say methyl. And I've got to put the di there to tell me that I've got 2. And then I need to say where are they at. They're at 4, 4, 4, 4, and we're done. Okay, so basically the same kind of thing, double or triple bond, it just means the ending changes, and I've got to say where they're at. If I have a double and a triple bond in the same molecule, then I'll be naming it like this, and it's alphabetical, so I would put the ENE first with where it's at, and the YNE last and where it's at. Okay? So we have aromatic compounds and benzene. These are rings. Now, if I do a hexane and make it a hexene with 3 double bonds, I get this structure that's on the left. But it could also be drawn as a double bond here, an H, a C, a double bond here, C, double bond here, and a C with the H's coming off like this. These are, whoops, sorry, it won't erase. These are the same molecule. We just don't know what form it's in. Now, since we know carbon has to have 4 bonds, we often just write it as a hexagon and show where the lines are. Now, because we don't know exactly where the lines are because they change, this is now the structure we're going to write for benzene, which just means a hexane or hexene with every other bond being a double bond. So anytime you see this, this is a benzene. So what is a benzene? Well, what happens here is we have what's called delocalized pi bonds, because every other one's a pi bond, but it switches back and forth. So instead of seeing every bond bonding as a double bond, we see just sort of what we see here on the right, sort of a fog over them, and they sort of share. Okay, so don't forget that carbons can only have 4 bonds. So in a benzene ring, only one additional group or element can come off each carbon. So the first one is methylbenzene, which is also known as toluene. The next one, we have 2 methyl groups coming off 2 different carbons, and since they're right next to each other, we have some things. This position right here is known as ortho, and the way I remember it is orthodontics are trying to get teeth as close as possible, and so we put an O in front of something if it's ortho. If it is in this position with the green here, that would be meta. I just met you, and so I need a little space. And then if it's in exactly opposite, that becomes a para. So I'm para, I'm exactly opposite. Whoops, that's supposed to be P-A-R-A. And I would put a P. So this one right here would be known as, since it's in the black, would be known as O dimethyl benzene. Or it could be known as 2-methyl toluene. 2 names it can be known by. Now, as we look at this next one, it shows 2 coming off the same thing. Well, I know that benzene can only have 1, so this is not a correct way to write a compound. So when I have a benzene ring, only 1 thing can come off each carbon. All right? So benzene, you in class, bring your questions. You like my little happy faces. We'll see you in class.